Ian Phillips is a Bloomberg Distinguished Professor of Philosophy and Brain Sciences at Johns Hopkins University. His work lies at the intersection of philosophy and mind and brain sciences. Particular interests include the perception, its relations to memory, imagination and belief, the scientific study of consciousness, and our experience of time. Concerning the experience of time, Ian edited a collection on the philosophy of temporal experience, which is now a classic and includes 28 original papers on a huge range of aspects of temporal experience. His works appeared in some of the most prestigious philosophy journals, such as Analysis, PPR, Proceedings of the Aristotelian Society, and Phillips Studies. He received many important awards and grants, including the Philip Leverhulme Prize in 2017. And I wanted to mention a very recent award he got with NetBlock, that is the 2021 Leibowitz Prize. So before leaving the floor to Ian, let me remind the audience that after Ian's talk, you can ask questions by writing in the chat that you have a question, and I will keep track of them. So this talk is recorded, and that's it, I think. So Ian, when you're ready, the floor is yours.
Thank you so much, Vera. See if this works. Okay, can everyone see a single slide?
Not yet. I'm confident. Soon we will be.
Okay.
Great.
Okay.
Great. Yes.
Great. Okay, thank you so much all for coming today. I'm really happy to be here. I'm obviously sad this is not in person, but what can you do? Okay, so today I want to discuss the famous phenomenon of blindsight, and in particular the argument of a forthcoming paper of mine. Here we are, where I reject the standard view of blindsight as involving unconscious vision, and argue instead that sight in blindsight is in fact conscious, albeit qualitatively degraded. And this forms part of a much larger project of mine, which I've been engaged in the last few years, where I'm kind of aiming to question the widespread assumption that we have incontrovertible evidence for the existence of unconscious perception. So today I'll start out with a short review, introducing both the standard view of blindsight and the degraded conscious vision alternative that I'm in favor of. I'll then consider a few popular arguments against thinking of blindsight in terms of degraded conscious vision, and show, I hope, why I don't think those work. And then I'll turn to some positive reasons in favor of my hypothesis before kind of stepping back and drawing a few broader lessons. So let me begin by introducing you to this man, Graham Young, or GY as he's known in the literature. When he was a young boy, aged 8, he had a traffic accident which led to a intracranial hemorrhage and ultimately to destruction of almost all of the primary visual cortex in his left hemisphere. So I'm sure most of you know these things, but primary visual cortex, or V1, is this area in the back of the brain. It serves as the entry point for visual signal, or it's the primary entry point for visual signal from the eyes as they begin their kind of journey through the various regions of visual cortex as part of the kind of visual hierarchy. And because of the way the visual system is organized, as the picture on the right of the slide is showing, the left visual cortex is responsible for processing information from the right side of visual space. So, I mean, if you had to make a prediction about what would happen if you had a big lesion to primary visual cortex on the left, you'd expect it to be, the effect would be to damage vision with respect to the right. And indeed it does. in fact, as far as Graham is concerned, the effect of his accident was really stark. His accident left him completely blind, as he sees it, on the right-hand side. So as he tells an interviewer in an interview from 2001, I've lost all the vision to my right. And he talks about the obvious functional consequences of that. So when he was 8, he literally used to walk into lampposts and so on. Now, clinically, Graham's blindness is confirmed by what's called perimetry. So here in this figure, what's being depicted is a test by Sturrig and Barth, again from 2001. And they just asked GY to indicate whether he could detect a bright white stimulus presented at various locations in his visual field. And if you look at the slide, then you can see a few white circles at the central portion of the visual field that actually corresponds to a little bit of spared cortex right at the back of the head at the occipital pole. But all the other circles, all the other radii are black circles, so those are indicating negative responses right throughout the visual field. So it would seem that he's blind. But of course, I wouldn't be talking to you about him today if that was all there was to say. What's so striking about Graham's condition and blind sight more generally is that from a behavioral point of view, it seems like he can see. And that seeing certainly includes visual processing. It also includes visual reflexes, ocular reflexes. But crucially, it extends to voluntary intentional discriminations. So here's a study from Weiskrantz, the person who's most associated with investigating blind sight, and colleagues of his in the mid-90s. And what it's showing, actually in a range of different paradigms, is that GY has the capacity to discriminate motion direction in this case. So it's slightly hard to read this figure, but at the bottom here is showing trial by trial reports of awareness. So you can see that he's reporting at stimulus speeds of 5 and 10 degrees, absolutely no awareness at all. And yet it's performing in this horizontal versus vertical motion discrimination task at rates of 80% or even like 95%. It's a very impressive accuracy. Lots of other studies of blind sight. I won't go through by any means all of them, but here's just a sort of sampling. GY was also shown to be able to discriminate emotionally expressive faces. So here, happy versus fearful discriminations well above chance, not quite 95% accurate, maybe 60–70% accurate, but nonetheless able to do that well above chance without reporting any awareness. In an earlier patient of Weisskranz's DB, he was shown able to discriminate between horizontal and vertical lines, also simple shapes like X's versus O's. So again, slightly hard to read figure here, but this is just showing you different sizes of stimulus on the X-axis, and then the number of discriminations correct out of 30. So chance is this blue line at 15. So for this horizontal versus vertical line, or X versus O, you can see performance well above chance at all these different sizes. Finally, GY is also able to perform well above chance in just simple detection of stimuli. This is a study from Bob Kentridge and colleagues, where GY was asked to say in which of 2 temporal intervals a high contrast black disc was flashed 3 times. So either the first or the second, in various regions of his visual field. So if you just look at this region here, where it says 100, what that's indicating is that in this region, he got 100 out of 100 of those detections correct. The 0 is saying that on none of those 100 occasions did he report any awareness. And this number below, 2 times 10 to the minus 14, is the odds of him having achieved that from chance alone. So really impressive capacity in the apparent absence of awareness. Okay, perhaps the most interesting patient is actually this patient, TN, who is sadly rather understudied, but suffered the misfortune of having successive strokes, first on the left and then on the right side of his brain. So he had almost complete destruction of a pretty large area of visual cortex. But as you can see, despite denying any awareness, despite not saying he had any idea how he did it, he's able to walk down this corridor kind of strewn with various bits of office paraphernalia. So that looks like successful navigation despite the absence of awareness. The kind of thing that would make you think, well, why are we conscious at all if we're able to do that kind of thing without awareness? So unsurprisingly, given what we've just seen, it's not surprising that many have hailed blind sight as a kind of revolutionary discovery. So here's Weisskranz in 2010, kind of retrospectively talking about the phenomenon. When it was discovered in the 70s, he said it was immediately obvious that the phenomenon of successful performance without awareness across a startlingly broad range of visual tasks must have a bearing on the neural and philosophical aspects of consciousness. And here's Pat Churchland actually talking in the context of Weisskranz's 97 book, Consciousness Lost and Found, of how the revolutionary blind sight results knocked the stuffing out of the, quote, obvious assumption that awareness of a signal is necessary for an intentional response to that signal. And I won't read these out, but these are 3 vision science textbooks I just happen to have around, and I looked up what they say about blind sight, and all of them report this kind of classic picture of blindsighters involving controlled responses, actions, discriminations of various kinds, despite there being no conscious experience, no awareness, no experience. And what I want to do today is to motivate a very different approach. So this kind of approach that I want to motivate takes its cue from critiques of some of the earliest work on unconscious perception, the kind of studies done on so-called subliminal perception in the late 19th century and early 20th century. And the kind of experiments that people did in those days involved reducing the perceptibility of a stimulus. So say the stimulus would be like a card showing a number or a letter, reducing its perceptibility until the subject in the experiment would say, well, I can't see what's on the card. And then treating that as kind of the threshold and presenting further stimuli in that condition. So maybe it would be like walking away from the subject, so to a distance such that at that point they said, I can't see what's on the stimulus anymore. And then presenting a card at that distance with another number on it and saying, I want you to guess whether this number is a 4 or a 5, or an X or an O, or an odd or an even number. And these results were really reliable and striking. Subjects turned out to be able to do significantly better than chance at these kind of forced discriminations, despite saying they couldn't see what was on the card. And theorists at the time were really impressed by this and made some pretty kind of heady claims about what these results showed. So this is Boris Sidis writing in his monograph on the subject in 1898, saying that this work tends to prove the presence within us of a secondary sub-waking self that perceives things that the primary waking self is unable to get at. Okay, and then in the 50s and 60s, kind of with the advent of what's called signal detection theory, another approach to this phenomenon gains ascendancy. So just to review, and I'm going to try and be as untechnical as I can in this talk. We can talk about technicalities in Q&A if you'd like. But really a central tenet of detection theory is that any perceptual judgment, of the kind, yes, there was a stimulus present, or that line was horizontal or vertical, or what have you, is something that arises from a combination of 2 things. Firstly, what we might call your visual sensitivity. So it's roughly how well you see. And secondly, something we might call your response criterion. So roughly how confident you need to be, something that's up to you. You can make, this is a flexible matter, how confident you decide you need to be before you're going to issue a positive response. Yes, there was something there, or the horizontal judgment. Yes, there was a horizontal line there. And the critical thing that the detection theorists emphasized was that this response criterion is a variable thing, something you can flexibly set as a participant. So just to give you one very kind of rough sense of that, imagine you're driving down the road, and out of the corner of your eye, you spot what you think is a cyclist. And now imagine you're driving down the road, and out of the corner of your eye, you spot what you think is a zebra. And I think it's really easy to imagine that you're going to be much more reluctant to say, oh yes, I saw a zebra, than a cyclist, given that presumably there's a much lower, in either of our neighborhoods, much lower probability, much lower prior probability of there being a zebra or a zebra on your street than a cyclist. So, one factor that a response criterion might be sensitive to, for example, is that prior probability. It's really unlikely I saw a zebra, so probably it was just a hallucination, or probably I just mistook, something, someone wearing black and white for that or whatever. Okay, so returning to subliminal perception, detection theorists basically suggested that all these results from these early theorists could be understood not as the perception of a secondary subwaking self, but rather as a weak conscious signal, weak conscious perception of a stimulus, falling below that subjective response threshold, which they suggested was, as it were, conservative. So they were suggesting that subjects might be underconfident as to whether they'd really seen anything, so say, no, I can't see what's on that card, but actually have some weak conscious signal there, and that signal be enough to facilitate performance in the relevant discrimination task. Okay, so we have this idea that a subject might be reluctant to judge or underconfident with respect to whether they saw something, despite actually having some residual conscious awareness, useful for performance. And now turning from subliminal perception in general to blindsight in particular, in the early 80s, this is a very important critical review paper in Brain and Behavioral Sciences by Campion and colleagues, which raised a whole bunch of criticisms of blindsight, which were basically met in Weisskranz and colleagues put a lot of work into showing that they were not, in the end, good criticisms. But also made this point, which is that actually blindsight might just be a matter of using different, in particular conservative decision criteria with respect to degraded brackets conscious vision. So maybe that's what happens if you have a lesion to V1. You have a serious reduction in visual signal, but enough conscious signal to do some tasks, but you don't acknowledge that because you have a conservative response threshold. Now, sometimes in the subsequent literature, this is called the hypothesis that blindsight is just degraded normal vision. So this is a paper criticizing this view by Weisskranz. I think that idea of the vision in blindsight being normal, I don't really know what it means for vision to be normal or not, but there's absolutely no reason to lumber this idea with the idea that vision is normal. It's very plausible, I think, that that massive brain damage and also the reorganization and degeneration in other areas of the brain that accompanies it might lead to qualitative differences in the kind of vision there is. The key thing I want to kind of press is that blindsight might still be conscious, even if it's qualitatively degraded. Okay, so that's the name of the view. Blindsight is qualitatively degraded conscious vision, not normal conscious vision. Okay, so let me just talk about the various results that we've encountered so far from the perspective of this theory and how this theory is going to explain them. So at the beginning, I showed you this perimetry from GY, where he says he doesn't see anything in all these regions of his visual field. Well, the qualitatively degraded conscious vision view is going to say, well, actually, GY is dimly conscious of stimuli in various areas of his blind field, but his subjective response criterion for a positive I saw it response is conservative, so he's reluctant to say that he sees things. And so the conscious signal is just not strong enough to reach that criterion, and hence he denies seeing things, and that's the plot we get. But what about the fact that I told you that GY could perform really well above chance in a detection task 100% in this particular region in the visual field. Well, the critical thing about this task is that it's a 2-interval forced choice task. And that's actually a pretty special kind of task from a detection theoretic point of view. So in these tasks, as I mentioned, you get a stimulus presented in either one or the other, but not both, of 2 temporal intervals. So it's either in the first or in the second, but not both. And the key thing here is that even if you don't think as a subject that you saw anything in either interval, as it were, the signal isn't strong enough to reach your subjective detection threshold in 1 or in 2, you have to make a decision. You have to say 1 or 2. And the natural strategy is just to pick whichever interval gave you the strongest signal, whichever interval you think is more likely to contain a stimulus, even if you think neither did. And because of that fact, these tasks are in effect criterion free, so they're not kind of subject to the vagaries of someone being conservative or liberal in their response setting, and so provide a pretty much direct assessment of how sensitive a subject is to what's out there, independent of their biases. So it's perfectly consistent in this kind of task that GY is getting information about the world, able to tell in which of those 2 intervals the stimulus is being presented, even though with respect to both taken independently of each other, he'd be reluctant to say he saw anything. And much the same can be said of these forced response discrimination tasks, where GY can say whether it's a horizontal or a vertical line, or in this case dB. The key point is just that it's perfectly consistent with a stimulus being such that it falls below a conservative detection criterion. I didn't see any line there, is the judgment, that there's enough signal coming through consciously to facilitate above chance performance in the horizontal or vertical discrimination. Okay, so in explaining these data, I've appealed a lot to this idea that there's a conservative, i.e. a kind of underconfident response criterion with GY. He's reluctant to judge that a stimulus has been presented or seen. Now, it must be acknowledged that to explain the data here, that conservative criterion has to be really conservative. It's to be really reluctant to say he can see, even though in certain cases he is sensitive to what's out there, sufficient to perform pretty well. So that's something we'll need to come back to and explain. But for now, all I want you to take away from this is that, theoretically at least, an account which says that there is only conscious perception of the world can accommodate the patterns of performance that we're seeing. So the real question is, should I believe this? And now I want to turn to a bunch of reasons people have said, no, you shouldn't. There's empirical evidence against the kind of view that I've been outlining so far. Okay, so the first objection, which is really Weisskranz's main objection, is that we can match performance across blind and sighted fields, and yet awareness will be reported in the sighted field, but not in the blind field. So how are we going to explain that? Now, it's certainly true that performance can be matched. Here we saw performance levels of like 95% in a motion direction discrimination task. Perfectly straightforward to find stimuli with respect to normal sighted vision that we could present in GY sighted field, where performance would only be 95%, just by degrading the contrast or something like that. The question really, though, is does that pattern where you get matched performance but differences in reported awareness show that the blind field vision is unconscious, as opposed to sighted conscious vision in the normal field? And the key point here is that actually the fact that sensitivity is matched, even if you use, for those who are familiar with it, a statistic like D prime or something to give an objective measure of sensitivity, even if performance is matched, that does not imply that the criterion that the subject has with respect to the stimuli, the two performances, is the same. And the reason for that is that what's you might call, following Kahneman, the criterion contents, basically the features or the nature of the stimulus, the bits of the stimulus, aspects of the stimulus used to make the discrimination might be quite different. And in particular, like this might look really different. Things might look really different in the blind field and the sighted field, and that may lead to a subject to set quite different criteria. So Kahneman's introduction of this notion of criterion contents comes in a paper where he's discussing meta-contrast masking. So that's the phenomenon where a stimulus, it might be like a black circle, is rapidly followed by another stimulus, like a black ring in a traditional kind of case, which affects the discriminability of the initial stimulus. So we say that first stimulus is masked by the second stimulus. And when you ask a subject to make a detection judgment, was there a black disk, for example, masked by that ring, or was there just a ring? Kahneman points out, following Sperling's work, that actually there are lots of different ways in which a subject might do that task. Now, the obvious thing to do, and clearly if the time difference between the disk and the ring is long enough, then you're just going to see the disk and say, well, I saw the disk, and I saw it really clearly, it was just there on the screen. But actually, there are other things a subject might do. They might notice that the mask was slightly different in brightness, or slightly different in contrast, or had this weird apparent motion associated with it. And all of those are signs that there was, in fact, a disk preceding it. So, in other words, you can do that task, detect whether there was a target there, based on how the mask looks. So those are the differences in criterion contents behind the target detection. Actually, this is really relevant to a phenomenon known as relative blind sight, where I, in fact, think that people kind of rediscovered something that Sperling and Kahneman had pointed out a long time ago. So this is a paradigm done by Hackman Lau and Dick Passingham in 2006. And what they did was present a target, in this case, either a diamond or a square, followed after a brief interval by a meta-contrast mask. So here the ring has an interior contour which matches both the diamond and the square. And they asked subjects to make two judgments. First, to say, was it a diamond or was it a square? And then to indicate on every trial how they made that judgment. Did they see the diamond or the square, or did they just guess whether it had been a diamond or a square? Now, the key thing they exploited was that the efficacy of the masking here depends crucially on the time between presentation of the target, the diamond or the square, and the mask, the ring. And the function you get is a U-shaped curve. So here what you're seeing is the percent of correct judgments as we increase the time between target and mask. And you can see that the maximum efficacy, where you get the poorest performance, is at this bottom of this U shape here, roughly kind of 50 to 67 milliseconds. Now, what was really interesting is that you can find 2 points where performance is matched here and here. So the percent correct judgments of diamond square are equally good at these points, but subjects report seeing much more of this stimulus onset asynchrony than this one. And Lau and Passingham interpreted this result to reflect different unconscious contributions to discrimination. So they said, look, there's more unconscious contribution to this discrimination, because look, people are saying they're guessing much more here than here. So this is relative blind sight. I mean, in both cases, there's some conscious contribution, but there's this distinctive unconscious signal. Now, is that right? Well, actually, I think it's not, and for exactly the reason that Kahneman pointed out. Because the key thing to realize is that the stimuli look completely different at these two different stimulus onset asynchronies, so times between mask and target. So when you have a big gap between the two, you can basically just see the target and whether it's a square or diamond like this. Okay. But at short SOAs, what you get is this kind of blending of the target, the square, and the diamond in the mask. So although you can still tell that this must have been a square and this must have been a diamond, you're not really, in some sense, seeing the diamond or the square, but rather you're seeing this kind of mix of the two stimuli. So it's really plausible, right, that subjects would be reluctant to report seeing at this short SOA, and more likely to say they guessed than at this long one here. And that would completely explain the pattern of performance we get without any need to postulate any unconscious signal. Okay, so now back to blind sight proper as opposed to relative blind sight. We can just imagine that things look different in the blind field to the sighted field, such that a subject is reluctant to report having seen something in that field, and more likely to say that they were guessing. And I'll come back to why that might be shortly. But the key point now is just that if the criterion is more conservative in the blind field, you can have matched performance despite a difference in reported awareness. You just need to appeal to a difference in how things appear in the two fields. Okay, second objection that very commonly made about blind sight and ordinary sight is that the functional profile is completely different. And that shows that we don't have conscious vision here. So sometimes that's talked about in relation to the claim that residual performance in blind sight is only revealed in kind of special experimental settings where you force the subject to make a response or a choice, or requires a kind of auditory cue, for example, to tell them they have to make a judgment, although there's some work by Sturridge suggesting that's not correct. And indeed, if you saw TN's performance walking down that corridor, maybe you don't think that was much in the way of a forced choice cued performance. But the most common way this kind of thought is expressed is by reference to a remark of Tony Marcel's from the 80s, where he says that a thirsty blind sight patient will not reach for a glass of water, or in fact, if you talk to Tony, a glass of beer in their blind field. Okay, so the idea is here that even if the subject is thirsty, they will not voluntarily and spontaneously reach out for the thing in the blind field. Now, as Marcel, I take it, knows, there's no way that a blind-sighted subject has residual vision sophisticated enough to discriminate glasses of water or glasses of beer in their blind field. So they wouldn't, this is a kind of fantastical example. But still, they can discriminate certain features in their blind field. So you might nonetheless run the objection, why don't they make spontaneous responses with respect to the visual features they can discriminate? Well, I think this is a really unpersuasive objection, given that the kind of view that I've put on the table already has suggested that subjects like GY are underconfident in their response criteria. So they're reluctant to say they see things, but similarly, any action on a detection of theoretic perspective is a combination of how sensitive you are. Any perceptual action is a combination of how sensitive you are to what's out there, plus some kind of criterion. So a lack of spontaneous report may just reflect a conservative response criterion for reaching out. And that's really not surprising. If the subject themselves doesn't really think there's anything there, they don't think they see anything in their blind field, then of course they're not going to spontaneously reach out. On the other hand, what's really clear from studies of blind sight is that there is visual information which is available to inform not just like eye movements, but voluntary actions. And traditionally, that would just be a completely standard ground for thinking that the information must be conscious. So I think if we're going to make a functional profile objection to blind sight, we should recognize that there's a pretty strong functional profile counter-argument, which says, no, this information has the signature of conscious information, namely availability to inform voluntary action. Okay, one more kind of objection to consider is alleged fact that the information in blind sight isn't available to so-called metacognition, or what sometimes people talk about type 2 awareness. So let me just explain this by talking about a particular paradigm. So this is a paradigm, a couple of papers actually, but one I'll focus on from Raj Pasau and colleagues. And they give GY a 2AFC task. So the task here is to say in which of two spatial intervals there is a horizontal as opposed to a vertical grating. Okay, so you can see that you either get this presented horizontal on top, or this, sorry, or vertical on top, or this presented where you've got horizontal on top. Okay, and you just have to make a discrimination as to whether, say, the vertical is in the upper or the lower. And after having made that discrimination, they asked GY to make a decision, a betting decision, basically, either to wager 50p, 50 pence, on his own discrimination, in which case he could either win 50 pence if he was right or lose it if he wasn't, or flip a coin. So take a 50-50 choice, in effect. If the coin lands heads, then he gets 50 pence. If it lands tails, he loses it. What they found was that GY exhibited much poorer correlation between his decision to bet on his own behavior and his correct discrimination than was found in his sighted field, despite performance being matched. So in other words, at a similar level of performance, you can do this task with really degraded gratings in the sighted field, so that we can see a similar kind of pattern of performance. He bet more often in line with making a correct discrimination in his sighted than in his blind field. And so the type 1 sensitivity is his sensitivity to the world, contrasting with type 2 sensitivity, which is sensitivity to his own accuracy in making correct discriminations or not. And the authors here interpret these results by way of thinking that GY's type 1 sensitivity, his capacity to discriminate the world, is not available to his awareness. Okay, so in some sense, again, there's this picture emerging that there's this, it must be that unconscious signal which is available to drive performance, but not available to inform betting behavior or metacognition. Now, I think these studies are really problematic on a number of grounds. Perhaps the most important thing is that the task here is actually, the betting task, is actually completely independent of whether the subject has any metacognitive awareness at all. So the correct strategy for any subject to adopt in this task is always to bet on your discrimination of, the up-down discrimination. But why is that? Well, even if you were completely blindfolded, so you really couldn't see what was on the screen at all, just taking wild guesses would by chance get you 50% correct, i.e. exactly the same as the coin flip. So you might as well bet on your discriminations, even if you have no confidence at all that you can see anything at all. And if there's even the possibility of you being a bit better than chance, then of course you should bet on your discrimination. So the truth is, GY and any of us should just be betting constantly and ignoring the coin flip option. So you can perform perfectly in this task, that is, even if you have no metacognitive access to your first order signal. Some other things to say though, the measure of metacognition used, this kind of correlation with betting behavior, confounds just in the way that first order perceptual judgments confound visual sensitivity and response criterion, so you can't tell from simply knowing how often a subject is saying, yes, they saw something, quite how visually sensitive they are, because you can't know what criterion they're adopting is without separating those things out properly. Similarly, the measures here don't tell you that. So in particular, it could just be that GY is really underconfident and so reluctant to bet on his discrimination in his blind field. Again, perhaps explained by the kind of nature of his awareness though. Okay, and finally, and just kind of much more philosophically in ways, it's just obscure what the significance of lack of metacognitive sensitivity would be. So suppose there really is, an objective measure of metacognition, if there's one available, which shows that the signal that is informing his first order performance is not available to metacognition fully. What would that tell us? Well, I mean, would that necessarily tell us anything about consciousness? I mean, one thing it might tell us is that there's somehow an additional source of noise or differential noise involved in making a metacognitive judgment, or loss of information between making one judgment and making another. So it's really not obvious that we can directly infer anything from a poor metacognitive performance. Okay, I'm getting conscious of time, so I think I'm not going to talk in any detail about this partly because it's rather technical, but it is worth noting that there's a kind of technical objection to blind sight, which revolves around the fact, for anyone who's familiar with these things, the fact that there's this dissociation, at least apparently, between sensitivity in respect to force choice and yes-no detection performance in blind sight that Azzopardi and Cowie uncovered. So I'm really happy to talk about that. I think it's actually pretty important in Q&A. The key thing that emerges from responding to this objection is that the criterion in a blindsided subject has to not just be conservative, but kind of wobbly. It has to move around a lot. And like I said, if you want me to talk about that, I'm really happy to in Q&A, but conscious of time. So let me now turn to some positive stuff. So I think what I've shown so far is just that there are no good objections, or at least the one I've considered are not good objections to the account. But why believe the account that blindsight is really conscious? Now, one thing you could say here, and I'm kind of inclined to think this is a reasonable thing to say, is just that the view that there's just a single conscious signal in blindsight is much more parsimonious. So in general, we're already committed to the idea that voluntary responding, voluntary discriminating is sometimes subserved by conscious awareness of phenomena. So if we can extend that hypothesis to all voluntary discrimination, then so much the better. But I'm not going to press any weight on that in what follows. I want to make two kind of more specific points. The first is that on standard understandings of the sort of detection theoretic framework, this response criterion that's postulated is a flexible thing. It's something that's the subject is in some sense in control of and can move around when various kind of manipulations are in play. So if blindsight is conscious but unreported because of a conservative criterion, we should expect to find evidence of reported awareness when those manipulations are made. And the second thing I want to say is that when you look at the behavioral data together with first-person reports from subjects like GY, actually you get a really satisfying explanation of why the subject would be responding in the way they do, that is conservatively and with this wobbly criterion I've mentioned. So let me turn to this first thing, varying the criterion. So one way in which you can vary a subject's response criterion is just by changing the question you ask of them. So I began with this perimetry from Sturrock and Barth, and here they were asking the question, press a button when you see something. Showing these stimuli in various locations and saying to GY, just tell us with a button press when you see something. But what I didn't tell you is that Sturrock and Barth also asked a different question. So this is a completely standard perimetry finding, but when they just shifted the question with the same stimuli to press when you're aware of something, suddenly you get this pattern of responses. GY is reporting awareness in lots of regions of his blind field. Now, Weitz-Krantz is perfectly aware that GY does sometimes report awareness, but he denies that that's really showing that there's conscious vision in blind sight. He says, no, this is type 2 blind sight, which is preserved residual vision but in the absence of seeing or in the absence of visual qualia or phenomenal content of the right kind. Now, I don't exactly know what that means, but I do think here it's much more parsimonious to think in terms of these reports of awareness as being reports of conscious vision. But another thing to say is that there actually are reports from GY himself of seeing things, not just mere awareness. So in that Kentridge study I mentioned to you before, the detection one, there were a lot of different conditions, and in one of them, GY was foretold that the disc was going to be presented or flashed at a particular location, a horizontal region of his visual field. And in that condition, despite the stimuli being the same, he was very accurate, 98% accurate, but reported awareness on 65% of the trials and said to the experimentalists that he was seeing a lot in that batch. So he does sometimes say that he's seeing. Okay, and I think one thing that may be going on there is that his prior probability of his expectation of seeing a stimulus in those locations has shot up, so his response criterion has correspondingly gone down. Another way in which we can manipulate a subject's criterion is by giving them more nuanced response options. So in particular, we can shift from a kind of binary, did you see it or did you guess, or did you see it or didn't you, option to a more nuanced scale where our response options are like 0 for no awareness at all, 1 for dim or degraded awareness, 2 for some awareness, and 3 for clear awareness. So this is the kind of response options that Ramsay and Overgaard proposed in a 2004 paper, which has been very influential. And that kind of perceptual awareness scale with those 4 options was used by Chiara Mazzi and colleagues in a blindsighted patient SL. And what they did, which was really intriguing, was compare performance in a whole bunch of tasks, first asking for binary reports of awareness, like, did you see anything on that trial or did you just guess? And then with exactly the same stimuli, look at her reports of awareness using this nuanced 4-point scale. And what they found, so if you look at the left-hand experiment 1, you can see that throughout most of these conditions, no awareness was being reported. So just some in the contrast discrimination, but and a tiny bit in the motion, but really not much anywhere else. But when you turn to the use of the perceptual awareness scale, you can see that this black bar for orientation suddenly becomes black for 0, but also significantly 1 for dim awareness. So looks like the black, I didn't see anything, is actually collapsing across 2 things, reports of nothing at all and reports of weak or dim awareness. And you can also see in relation to the contrast case where there was reported awareness seen in this case, that this is corresponding to level 2 on the scale of some experience, whereas the black is all pretty much corresponding to dim. So I think this is very suggestive work. I think what it's suggesting is that when patients are given a binary scale of seen, didn't see, they choose to use unseen to report no and very limited awareness, and they choose to use seen to report clear and almost clear awareness. And interestingly, although it's a little bit difficult to know how much to take away from this because the performance in a lot of these conditions was pretty poor, there is no evidence in this patient of any performance above chance when you only look at this occasions where you've got 0 being reported. So there's only above chance performance in cases where you've at least got dim awareness being reported. Okay, I'm going to skip the next thing, which is another case where I think we find evidence of manipulations of criterion revealing reports of awareness. And I want to turn to the kind of final piece of the talk, which is this kind of question: what is it like to have blind sight, if I'm right that it is in fact conscious? And there'll be 2 pieces to this. First, the behavioral piece, and second, a kind of phenomenological first-person report piece. So the first thing to say about blind sight is that it's really, really the graded vision. So when you look at the kind of general profile of the vision, sensitivity to features like wavelength or orientation are like an order of magnitude worse than, you know, neurotypical vision. Like contrast sensitivity, like 2 orders of magnitude worse. So you might think, well, didn't you tell me you could see X's and O's if you had blind sight, or, you know, detect form, which would seem to be something. But actually, it turns out that DB, the original patient, couldn't do many similar shape discrimination tasks. Couldn't tell whether a triangle was upright or inverted, couldn't tell whether it was a square or a rectangle. So what Weisskranz concludes from this is that in the X versus O task, DB is not actually discriminating form at all, but rather is sensitive to probably just the fact that there's an oriented line in the X and a curve, like a straight line in the X and a curved line in the O. So has some sensitivity to orientation or curvature, but can't put those elements together in anything like the way that you'd need to see a letter or a genuine shape. So this idea that there's really very limited vision in blind sight is really brought out by this nice study from Eleanor Alexander and Alan Cowie. So they were looking at with a couple of patients including GY, at what the basis of his capacity to detect stimuli was, and made 2 manipulations which are kind of key. One was that they contrasted performance with stimuli with sharp edges, like the circle, which has a sharp contour, in contrast to this patch here, this Gaussian, which has no sharp contour. And they also contrasted performance depending on whether you quickly put that stimulus on or off the screen, so it like rapidly was presented like that, or whether they faded it on and off the screen. So they just took it away very slowly or brought it back onto the screen very slowly. And what they found was that if you get rid of the sharp edge and you, instead of just flashing it on and flashing it off, you fade it on and fade it off, then you completely abolish performance. So it looks like, although GY could perform well above chance in a detection task where he was asked, is there a stimulus on the screen or not? It's not really detecting the stimulus, as opposed to there being some kind of sudden on or offset. So there's some change in space, a sharp change between this part of the screen and this part of the screen, or a sharp change in time, i.e. suddenly there was an event happened. So Cowie and Alexander comment that maybe actually GY is not really able to see objects at all. He's really only able to detect events, so differences in what you might call subjective salience. So that idea goes back to Humphrey's early work on blind sight. And so there's this idea that, you know, instead of actually seeing objects in the world, you might just see regions of space as somehow, or periods of time as somehow just different in some way. Maybe there's no specific feature being attributed to the world. It's not like he's seeing an object or seeing a green thing or anything like that, but just like there's something funny there, or there's some difference there, or something stands out, or something has happened. Okay, so turning now to what GY says about his experience, let's compare that with that behavioral data. So what does GY say? Well, he stresses that he doesn't have any color sensation. He says sometimes that he's aware of individual functions of sight, like sometimes he's aware of a motion, but the motion has no shape, no color, no depth, no form, no contrast. Sometimes I can tell you what orientation it's at, but then we lose everything else. So that suggests there's no binding together of features into kind of unified objects, percepts. In relation to motion, he says that moving objects don't appear to have any color or shape. They look like shadows. And kind of somewhat more poetically, he says sometimes motion looks like black on black or a mouse under a blanket, similar to that of a sighted man who with his eyes shut against sunlight can perceive the direction of motion of a hand waved in front of him. And finally, and kind of really interestingly, with really low contrast stimuli, in one study, GY just spontaneously remarks that in this condition, his awareness score should be -1 or -2. So one thing to say about that is that surely unawareness doesn't come in degrees. So either you're unaware or you're not. So this suggests that given he is thinking of unawareness in degrees, that actually he's using the label not aware or not seen to cover some degrees of awareness too, much like that patient in the Matzi study was using the unseen response to collapse guessed and seen responses, sorry, dim and completely absent awareness responses. But the more important thing I want to take away from this description of what it's like to be GY is that it fits really nicely with the idea that something is really different about vision in the blind field. There's no color, there's no binding of features into objects, there's no visual form. There's perhaps only representations of, just a particular feature and how much it stands out. So that might be motion or orientation. Perhaps there's just, as it were, feature agnostic salience, like a sense of there being something there. Okay, so how do we draw on these ideas to explain why GY might be so reluctant to say he's aware of anything, so conservative in his responding? Okay, one thing to say is that actually all of us are pretty reluctant to say we're aware of things when our vision is degraded. So this is data from Anders Sand, his PhD thesis, where he just, for kind of illustrative purposes, took a bunch of neurotypical subjects and showed how their response threshold, this is how conservative they are, how reluctant they are to report the presence of something, and higher numbers are more conservative, is affected by how sensitive they are to what's there. So this is a masking study. And what you can see is that pretty much everyone is conservative. And moreover, as vision gets worse, as D prime gets lower, people trend more conservatively. Now, what I've done here, this is a little bit hand wavy, is plot roughly where you might expect to see GY in relation to the kind of conservativeness that he exhibits with respect to the kind of sensitivity he exhibits. And that's that red dot here. And so what you can see is that GY is an outlier for sure, but he's not completely off the chart. So if GY has D prime of roughly 1 and the criterion of roughly 2 here, then that would explain a lot of the data, and here he is. Now, we also don't know how representative GY is of the population, which we can see is really variable here. So possibly other blind sight subjects wouldn't be this extreme. Okay, the second thing to say is that the criterion content, i.e. the basis that GY is making his discriminations on, is very, very different from neurotypical sight. And in ways that make it very understandable that he's reluctant to call it vision, right? I mean, did you see anything? Well, in a sense, he didn't see anything because he doesn't see objects. He has maybe some sense that there's a feature that stands out or something funny about that region of space. But that kind of degraded awareness is not necessarily something you'd want to report using the vocabulary of seeing, especially when he's only got the two options. Did you see anything or didn't you? One other thing that's really important to notice about GY in particular, who's the best studied blind sight patient and one whose lesion has been very carefully mapped, is that he's been studied extensively for a very long time. So for one thing to know about him is that he's been blind since he was 8 in his own estimation. And since 21, when he was first sort of encountered by the neuropsychological psychophysics community, he's participated in a huge number of studies. And these psychophysical studies are really long and boring. So he's done a massive service to science. But in doing them, he's also got to know his experimenters very well. he reads his own literature, so he's not a naive subject. And the people who study his condition, in particular Weisskranz before his death, were strong proponents of the hypothesis that GY's vision was special in that it was unconscious and operating outside of awareness. So there's a sense in which GY's commitment to science and his relationships with his experimenters is not going to leave him a neutral party. So it's quite possible that these factors lead to biases. And it's very clear from reading the literature that GY does, in fact, try to guess what his experimenters expect him to say in different conditions and perhaps respond in line with those expectations. Okay, I won't talk about this. This was a slide talking about how we might explain on the basis of the kind of vision GY has, why his criterion is not just conservative, but wobbles around. Again, happy to talk about that. But let me just end by talking about some lessons and maybe some future directions. So the first lesson that philosophers and scientists interested in consciousness were inclined to draw from blind sight was that it just was a counterexample to this traditional idea that in order to make an intentional or a voluntary discrimination of a stimulus, you had to be conscious. So if we found intentional responding to a signal, then that was evidence of conscious awareness. Well, if blind sight isn't unconscious, if I'm right that it's degraded conscious vision, then maybe we can hold on to that assumption. So I think there's something really natural and attractive about that obvious assumption. So the first thing to say is we should, again, take that hypothesis seriously. Second thing we should do in more of an empirical vein is consider whether the host of other conditions which people have put forward as examples of unconscious vision in brain damaged patients are equally amenable to an interpretation in terms of degraded but conscious vision. So that would include neglect, prosopagnosia, so face blindness, in the memory literature, amnesia, and in the kind of action and perception literature, visual form agnosia and patient DF in particular. We also ought to consider the same for cases in relation to alleged instances of unconscious perception in neurotypical vision. So let me just very finally advertise something that I'm currently working on. So this is a study, an empirical study done with some colleagues of mine at Hopkins, investigating inattentional blindness. So I'm sure all of you have seen this famous video where you're asked to count the number of passes made by the white players with a basketball. And in the middle of doing so, this gorilla walks into the middle of the group, and subjects afterwards are asked, did you notice anything unusual on that last trial? Or did you notice something unusual when you were watching the basketball? And maybe half of the subjects say no, they completely seem to miss the gorilla. Well, this is work that was more kind of rigorously studied by Mack and Rock using a cross task where the primary task wasn't counting basketball passes, but was trying to judge which of two lines were longer than each other when very rapidly flashed. And lots of people have, and in the middle of this study, something unexpected would be presented, and subjects would maybe 70% of the time miss it. But lots of people have said what this shows is that if you're not attending to a stimulus, you aren't conscious of it. So attention is a requirement for consciousness. That's what Mack and Rock said, but a philosopher like Jesse Prince would be one of the advocates of that kind of view. Well, in our study, we present an unexpected stimulus and just a simple red line, and the red line appears either on the left-hand side of the screen or on the right side of the screen. So you get simultaneous with the fourth presentation of this cross task, you get one of these stimuli. And the purpose of having the line either on the left or the right is so we can ask subjects two questions. Firstly, did you notice anything unusual on that last trial? But then of all the subjects, we ask them, okay, there was something unusual. It was a red line. It was either on the left or the right. Even if you don't think you saw anything, guess which side it was on. And what we find is that even amongst the people who do not notice anything, say they don't see anything unusual, they are still significantly above chance actually both in relation to location and also in relation to color judgments with respect to that stimulus. So here's another interpretation of inattentional blindness, a bit like the blindside interpretation. Subjects do have weak, degraded vision outside of attention. They're reluctant to say they saw anything because they're underconfident whether they did, but actually, when you look at their forced choice performance, that reveals they really were visually sensitive to the properties of the stimulus and can make an intentional discrimination. Okay, so maybe it's not inattentional blindness, it's inattentional degraded vision. And with that little teaser of a larger project, I'm going to just say thank you so much for listening.
Thank you very much, Ian. That was great. Thanks a lot. Okay, so let's see whether there are questions.